You know, one. All right, guys, we all agree with subject 4 and subject 8 that we can eliminate those, right? And number 1. Okay, so for number 2, some of you are getting confused with this one and actually just like what it means. Like you could find the averages, I think that's fine for everyone, right? Finding the averages. But then how do you decide who had the least accuracy? Okay, so let's just quickly look at the values. Are we all in agreement that suspect 1 was 7, 10, 8, 5, 11, 10. You guys still with me? Have I lost you now? So you can see the numbers on the side here, hey? So those subjects, we're just quickly marking the averages. What? 2. Right, subject 5 was 11, subject 6 was 10, subject 7, 14. I'll explain now why I highlighted subject 7. Subject 8 was 6, suspect 9 was 16 millimeters, and then suspect 10 had an average of 12 millimeters. Okay, we'll all find those values. Now, guys, they said that the accuracy is how far off the target is. Now, do you think you're a better shot if you are shooting far off the target or close to the target? Close to. So, guys, the bigger than this value is, the worse of a shot you are, right? Because if you have an average of 16 millimeters off target, I mean, that's quite a lot, right? Does that make sense? So for this one, you actually have to choose the 2 with the biggest average. Okay, it was important that you read in the description that they said how far off the target in millimeters. So guys, if you are 5 millimeters off target on average, that means you are a good shot. Hey, that's fine. Okay. But the biggest 2 values here, were 14 millimeters and 16 millimeters. So that was for suspects 7 and 9. Does that make sense, guys? The bigger average is actually the one that you have on target. Alright, so if you got these ones wrong, you go to 7 and 6. You will make it eliminate suspect 7 and 9 from evidence 2. Okay, so go fix that on your table if you got it wrong. So far, we will have 4 suspects that have been eliminated, right? Was it 4, 7, 8, and 9? Right? Those are number 4 that are eliminated. Okay, perfect. So what? 7 and 9. Okay, guys, the next one was for the range, right? They wanted to know how consistent the people are. So guys, we actually spoke about this yesterday when we marked under that question, right? Where we said one of them was more consistent than the other one because his range was 8 millimeters. So there was a smaller difference between the highest and the lowest values than the one that had a range of 15 millimeters. It was the same concept here, right? We had to eliminate the 2 suspects with the least consistency. So you didn't have to write the working out exactly like I did here. You could have just written the answers. Do we agree that for suspect 1, the range was 10? Suspect 2, it was 32. Suspect 3 was 15. Suspect 4 was 8. Suspect 5 was 23. Suspect 6 was 16. Suspect 7 was 13. Suspect 8 was 19. And then you had 10 for suspect 9 and 51 for suspect 10. So guys, what we wanted here was actually the highest 2 values. Okay, thank you. I think some of you would have done the smallest 2 values because we thought least consistency of the smallest number. But we need to think about what this number actually represents, right? It's the difference between the highest value and the lowest value. So the bigger that difference is, the less consistent the people are. Does that make sense? This is a really big thing. One time was the picture shot on top. One time he hit the target, but then another time it was just what? Oh, that's very inconsistent. Okay, you can't really say because he hit the target once, he's gonna hit it every time, right? Because look what happened the second time. We're very cold. Okay, where if we look at someone with a rate of thing, it's not great. It was the first that he got, but at least he wasn't very far off with it. He didn't go to 51, right? You see, he was 21 with the first one. So for this one, guys, the two biggest ranges that I got was for suspect 2, which was 32. So I eliminated suspect 2 here, and then suspect 10 was 51. So suspect 2 and 10, yes? Suspect 2 and 10, if you got it wrong, we can do the table, please. Suspect 2 and 10, you were meant to eliminate those two for evidence 3, 2 and 10. All right, let's look at the next one. Let me zoom out a bit. Okay, guys, this one you have to follow points. So what I didn't like about this question is they didn't actually tell us what value was on which axis, right? But if you look at the numbers, you could figure it out. So this on the y-axis we have height. So if you just add height there, right, height, and then on the bottom axis, the y-axis, it was weight. So what you have to do, guys, is you have to plot all of the points, right? Now each suspect is 1 point. So if we're looking at suspect 1, we had a, or he or she, I don't know, had a height of 193 centimeters. So you need to go on your height axis to 193. Do we agree with that line there? That's 193. 3. Oh, okay. 193 centimeters and a weight of, what is this? 66 kilograms. Okay, so on your x-axis, you have to go 2, 4, 6, and then go all the way up. Okay, sorry, it's a bit difficult to see, but that is suspect 1. And that was also good. I just put the number of the suspect next to the points here. Because if we didn't do that, how are you going to know which ones were out? Okay. If you plotted all of your points, you can't get those points. More or less. Okay, if you got those points, I'm hoping that you can see that these values are all kind of going up, right? It's almost forming like a bit of a curve there. You could almost like draw a curve going kind of towards those points. But these two are way off the rest of them. Okay, so we say that these 2 points do not fit the trend of the rest of the points. The trend is kind of the pattern that we see emerging, right? That is kind of going up like that. These 2 points are way off. So those are the 2 that you have to exclude here, that you have to eliminate. Suspect 1 and 3. Suspect 1 and 3. This was what? Evidence 4. So if you didn't get that on your table, go to these. For evidence 4, you have to eliminate suspects 1 and 3. Yeah, are we fine? And guys, evidence 5 was actually quite tricky. They gave us the pie chart, right? Have you guys done pie charts in bio? A little bit. Okay, we'll practice, we'll do some pie charts tomorrow as well. I'll just show you step by step how to draw it. But you have to kind of work with the rate here, which I wasn't sure if you guys would be able to. They said in this paragraph here, 20 of the witnesses thought it was suspect 1. About 20 people thought it was suspect 1. What percentage was suspect 1? 10%. So I'm just going to say that 20 people was 10% of the data. Hey. So we hear that, guys, 20 witnesses made up 10% of the data. Alright? So now they're saying we must eliminate anyone with less than 5 witnesses. So we want to look at the percentage. We actually need to figure out what percentage is 5 witnesses. Does that make sense? We're not going to look for 5%. They didn't say 5%. They said 5 witnesses. Okay. So I want you to please copy down the working that I did here at the bottom. If you just kind of did it by inspection, that's also fine. But I do want you to have like a calculation. So 20 sources of suspect 1, right? So that's what they told us. Then on my pie chart, I saw that suspect 1 was 10%. Okay, so do we understand that first line that I wrote in? 20 witnesses is 10%. Okay, so I just wrote that there. Therefore, 10% is equal to 20 witnesses. What did they say? We can eliminate anyone with less than 5. So that I need to figure out what percentage is 5 witnesses. So now how do I go from 20 witnesses to 5 witnesses? What do I do for 20 to get to 5? I have to divide by 4. Do we agree? So then you must do that to the percentage as well, right? I'm going to say that again. We were given that 10% is 20 witnesses. Now I need to look for on the pie chart, where do we have less than 5 witnesses? So I want to change 20 to 5, right? Because they told me less than 5. So that's why I want to change 20 witnesses to 5 witnesses. What can I do to 20 to get to 5? I have to divide by 4. Are we all kind of that step, right? We all know that 20 divided by 4 is 5. So now we said that 20 witnesses was 10%. So now what I did to the 20, I divided it by 4. I must do to the 10% as well, guys. What is 10% divided by 4? 2.5%. So when they say less than 5 witnesses, I actually have to look for less than 2.5%. Okay, that was a tricky one. So we had to look on the pie chart for anything that was smaller than 2.5. I'll just leave that after start so that everyone can have that down. And on the pie chart, you can actually see I highlighted them here. There were only two of these sections that were less than 2.5%. That was the orange and the purple. Are we fine with this? Copy it down. All right, guys. So the orange was suspect 6 and the purple was suspect 4. So from evidence 5, you could eliminate suspects 4 and 6. Sorry? 4 is already eliminated. We can just do another cross. Okay, now let's look at my table. Subject 1 was eliminated, subject 2, subject 3, subject 4 was eliminated twice. Alright, so we're very sure that it wasn't that person. Subject 5. That's the one. I said that. That's why. That's why all the others were eliminated. Alright, guys. Alright, guys, this was the answer. Subject 5. I wrote it down. Did you just look at it and go like, so much? It is, but everyone thinks you have to just write that. All right, guys, I'm going to give you. No, it's not a worksheet actually for a change. I'm going to give you some interpretation questions. We just need to write a few notes down. So I would like you to make a new heading, analyze and interpret graphs. Do you guys enjoy this exercise? First of all, I did it. Wonderful. Okay, analyze and interpret graphs. Okay, guys, this is also the last, thank you. This is the last topic that we are doing for the year. So we're gonna make a note now. We're gonna practice a bit. We might practice some more tomorrow. But I think tomorrow we're gonna start doing some revision. And then next week we're going to do some very important revisions. Alright? I don't want you to think, oh, we're doing revision. I don't have to come to school. I think we all need revision, right? Not even thinking about the class test, because that's not going to be in your exam. But all that algebra stuff, solving equations, all the geometry, things that we haven't done for ages. Right. So we do really need next week 4 days to go through all of this. Okay. All right, guys, basically a graph. There are lots of different types of graphs, right? We've looked at bar graphs, we've looked at a scatter plot, that's one where you have to plot the points. We've even done graphs where you just have coordinates and you plot them, right? So all sorts of different graphs, but a graph can be used to describe a relationship between two variables. That's actually the purpose of any graph. Okay, have you guys heard of dependent and independent variables? Yeah, let's just quickly write that down. Right, guys, there are lots of definitions of dependent and independent variables. Basically, what it comes down to is the dependent variable is the one that is affected by another variable, often the other one. Okay, we'll look at an example now. What is important, guys, is you need to remember that that variable always has to go on the y-axis. Which one is the y-axis again? We have this one and this one. The y-axis is this one. Okay, good. An independent variable is not affected by the other one. The most commonly used independent variable is time. Right? Time is going to pass, right? Whether you are 160 centimeters tall or 170, time is still going to go. All right? So time is usually the independent one. It can be something else as well. The independent variable is not affected by another variable. And the independent variable is always going to go on the x-axis, which is the horizontal one, this one, right? All right, there are just two more terms that we just need to write down. The first one is a discrete graph. And we have kind of referred to this, I just think not with the term. A discrete graph. Is a graph made up of points that are not joined by a line. And guys, this kind of graph is usually used for things that can be counted. I'll explain the difference now once I've written the other one down. Oh, I'm so sorry, I'm not sure why that happened. All right, the continuous graph is a graph made up of points that are joined by a line. All right, and this is usually for things that are measured. So, for example, height is something that's measured, not counted, right? You don't count your height, you measure your height. And the reason why you can draw a line is you have like points showing different heights and you can join them with a line because you can have in between heights, right? Someone can be 160 centimeters tall, and then you're not going to magically jump from 160 to 161, right? You're going to go 160.1, 2, 3, right? You're going to move kind of gradually. Yeah. No, so it depends. I'm talking about when you have points. Do you guys remember when we did those little worksheets with number patterns? There was one with true sides. Remember that one where you have to plot the points. And then I will explain to you guys that you can't join those points because you can't get like a 3,8 as a true side, right? You have a 3, and then maybe you have a 3.5, and that sort of thing, and then you have a 4. Okay. So you have very specific values. You don't have in between them. Okay. All right, I want us just to look at an example quickly. I'm not going to ask you guys to draw it because it is in the textbook. So I'm just going to write the example on page 256, and then I'll put the example on the board. But I do want you guys just to write the page number so that if you want to look back at this, then you know where to go. And what we're going to do is we are going to write the answers down in our book. Okay, so we're not going to write the questions down, and we're not going to draw the graph. But you can look on page 256 at some point in the future if you want to. Okay, this is the graph. They are saying that this graph shows the rainfall over the last 7 days in Cape Town. All right, so this is a line graph that's not joined, right? So would we say that this is discrete or continuous? Discrete, right? Because the points are not joined. Okay. Yeah. No, so that's not what we mean by continuous. When I say continuous graph, I'm looking at this. Is it separate points? Then it's discrete, or are the points joined with a line? Okay, but time itself is continuous. Okay, so 1A, identify these features, the dependent variable. Time or rainfall, guys? Rainfall. It's actually very easy. If you remember that the dependent variable is on the y-axis, it's just going to be the one on the y-axis. Okay. But guys, do we agree that the days of the week are not going to change based on how much it rains? Does that make sense? Right? But on Monday, maybe it can rain. On Tuesday, it won't rain. On Wednesday, it can rain again. So the rainfall depends on the number of days here. All right. So for, what is this? 1A. I'm just going to write here dependent variable is the rainfall. Right, B is also for the independent variable. I don't know about that. Yes. Okay, the independent variable, that's the next question. That is time. Guys, I'm just going to add here as a note. Remember that this one is on the y-axis and that one is on the x-axis. All right, so if you're not sure which one is which, look at the axis that it's on. All right, for C, they're now asking us for the maximum value. I'll show you now on the graph. I'll put that up on the board now. Maximum value, guys, what do we think is the maximum value here? That point over there, right? The highest one is literally the maximum one, guys. It's not like a trick question. It's also the highest point. That was 15 millimeters. Okay, please don't just write 15 millimeters. All right, for D, so you guys can guess what they're asking in D. What is the minimum then? Minimum value, what do we think? 2. 2 what? Millimeters. It was on day 2 or on the second day, but we need to always write the actual value on the side, the millimeters. So 2 millimeters. And then for question 2, we have actually already discussed this. They're asking, is the graph continuous or discrete? And explain why. All right. So again, if we're just looking at the picture, we can see that we have separate points. They're not joined by a line. So this is discrete. Okay. So we're going to say discrete. And as your reason, guys, it really is as simple as saying the points are not joined. Or you can say they are separate points. So discrete because the points are not joined. Right. So I'm going to give you a few questions to practice on your own. They are on different pages, so I'm hoping that you guys do have your textbooks here. If not, maybe you must take a picture of someone's. So the first question. So I think I'll be able to put question 2 on the board. I don't know if 3 will also fit, but I'll put question 2 up. Oh, guys, we're going to do a client talk example tomorrow. I must remember that. Okay, write that down, please. So I can put number 2 up for you. Okay, there we go, guys. That's number 2. The flag on. Sorry, I'm in the zoom out now. I wanted the whole graph and all this. Number 3, the questions are on the board, but the graph is underneath, so you won't be able to do number 3 unless I move it up. But I can do everyone's number 2. So what do you think? What do you think linear? Is that one straight? Okay, then what do you think constant? Okay, the word constant. Something stays constant. So then what do you think that constant?